All right, thanks for joining me for my colleague to colleague last assignment number 6 here. Let's get it going here. Going back to my activity that I created back in module 2, I had created an Amplify lesson. Amplify is a web-based platform. It embeds the students' computers, each of their computers, digitally with each other, and allows us to basically have a in-class lesson. We could do it remote or in the classroom, and each student could give feedback. We could put the students in groups. We could isolate the students by themselves, but it's a very collaborative and feedback-oriented platform that allows students to work together or work independent and lets the teacher lead and then give students the lead themselves. Today's lesson is going to be on domain and range. We're going to introduce those terms. We're going to talk about what domain is as the independent value. It's the X value and it's the input for our function, how we find those values on a graph and how we not only graph them, but write them in inequality form, as well as we're going to learn later to write them in interval notation. We're going to do the same process with the range. The range is the Y values of the function that is given. Okay. So the lesson, here's what the dashboard for Amplify looks like on my lesson. Again, these are the slides right here that we use in class. This is the teachers. I took away all the students' names that are in this one. You can see what slides I've had people on earlier. But this is the teacher slides that we can anonymize. I can stop the pace. I can sync it. I can pause it. I can let students go. So I'm not going to take you through all the slides, obviously, because there's about 30 of them. But that's what it looks like from the teacher's perspective. All the students would have these individual slides placed on their screen as we work through this, okay, as we go through it, obviously, at the beginning together, okay? So starting off this first with modeling, how would I model? I would start by logging the students in, get them in through Google Classroom. We would link up through our Google accounts. We would put in the classroom code, and then it would link us to the Amplify lesson that I've created, and then we're going to demonstrate together. I'm going to show, number one, how to find X values, how to find Y values for domain and range, and then we're going to use the vocabulary correctly to identify these, and then finish with inequality signs and interval notation. Okay, I thought on the first one here, I thought that 3.A, formulating computational solutions, was the IST computational thinking standard that I really like because we're modeling and learning with the students how to formulate computational solutions to the problems that we give. Okay. The second part is we're going to integrate interval notation, which I just alluded to on the previous page. Now, this is a concept they don't have any background knowledge on. It's going to be a new concept. So we'll really have to establish, how this is done for our set building notation. You're going to have symbols with parentheses and brackets that are going to be used. So this is a varying approach here. This is a kind of a wrinkle in our approach here. That's why I chose 5-point-C as my standard. It's going to frame the problem in a different way, and it's going to be performed similar to with inequality signs, but it's going to be just a little bit different in a form that's new to them that we'll use in college algebra. Okay. Third, gradual release of responsibility. So on the first slide, we're going to start together. Once I get them on, I'm going to take them through this maybe 1 or 2 times, probably just one time. I'm going to demonstrate, show them all the steps of finding domains, explaining with reason in inequality form, and then challenging them with interval notation at the end, okay? Students will watch the first time. The second time, we're going to work it out together. Again, I'll go very slow through this entire process, go into the graph, finding where our domain, our X values exist from endpoint from left to right. And then on the third attempt, they're going to work these independently. And I typically, after I work them independently, I like to pair them up, collaborate with a partner, and then we share out our answers as a class on Desmos. It's called Amplify now, sorry, Amplify. And we can see our answers there together. That's what the beauty of our platform does for us. Okay, so I chose student collaboration as our standard. It's an effective teaching strategy that helps students collaborate with their various roles and equitable workload. They're both all going to work on the problems, and they're going to share together, work together, and share out after they get done. Encouraging, I'm a big sandwich effect person here, where you give a positive, some sort of optimism, and then give them the feedback, be critical, and then end with some sort of optimistic approach. Again, I think you got to really celebrate effort and resiliency, encouraging kids to keep trying, keep working hard. Problem solving strategies. I typically like to have kids go back and relearn, or our forgetful selves, as I call us. That's why we took notes and we go do our learning from there. And recall from there instead of just giving them the answers. I think reasoning needs to be praised. I think you need to normalize our mistakes that we have. Okay, everyone makes mistakes, including myself. And then I love a not yet mindset where you haven't done it yet, but you will get it. You will get it on your own. Okay, so the standard I chose there was developing a growth mindset. 1.D. Resiliency is important, perseverance is important, and then building comfort with the struggle and the uncertainty if you're going to be successful or not. Okay, questioning. I love to probe for understanding from my students. I think this is a great assignment or activity that you can do this with. How do we know the X values exist with our domains? Where did the function end or begin at? Just why is the endpoint open? Why is it closed? Why is it filled in? Why is it not filled in? Is that part of the set or not part of the set? Those are the questions that we need to keep probing our students for understanding to see if they've learned what's going on. And I think that this lesson here does a great job of embedding those questions in. I have those questions put into our discussion as we go through these slides. Is what's nice. So students can not only respond out loud in class, but they can respond on their computer and they can see their classmates' responses as well. It's a really neat program that we're using. Okay, so designing authentic learning activities was my standard 4.B. Gives them the ability to leverage and design processes to solve problems with awareness of technical and human constraints and defend their design choices. Okay, defending their reasoning. All right, alternate problem solving would be number one. And then we go to the range values. What are range values? Range values are the Y's. That'd be our alternate problem solving solution. Now we've done X's. Now let's see if we can do Y's without me having to instruct it. The biggest question will be, do we start at the top or the bottom, which we'll go back to. We always go least to greatest. So we'd always start at the bottom or the floor of the graph and work to the ceiling or the top, because the smallest values for Y's are at the bottom. The largest values are always at the top of the graph. Okay. Alternate two would be flipping the script. And now I would give them a domain in either interval notation or inequality form, and then they would provide me a graph. Again, the graph could be any of the, it's a piecewise, right? We haven't talked about vocabulary yet, but it's going to be a piece of a graph of a function, and they just have to graph, any of those constraints from endpoint to endpoint on that domain that's given, and do the same thing with a range. Okay, getting them to think in a different vantage point, and that's why I chose 4.D as my standard. Okay, changing our vantage points and our viewpoints to build or use creativity and enjoyment and fun in the process of learning. Okay, computational thinking vocabulary that's going to be used is, the values that we're going to use, X and Y values, input, output, domain, range. These are all math vocabulary. Piecewise functions, endpoints included, excluded, open and closed for those endpoints, interval notation, continuous and discontinuous of a function. Those are all vocabulary words that we use throughout our math department, and we are aligned as a school to use those and to define those in a certain way. For computational thinking, we're talking about identifying, creating, sharing, analyzing, describing. Those things are going to all happen in this lesson. So I think it's really important to nurture a confident, competent, and positive identity around computing for every student. Learning the vocabulary builds confidence, builds understanding, and builds ability to understand or know what we're going to do and how we're going to solve or simplify or proceed with identifying, creating, sharing, analyzing, or describing what is asked. So that's why I chose 2.8 as my standard. Okay, challenges for this lesson, why and the workaround. The biggest why that we're going to have is the interval notation when we integrate that. That's never been learned. Students don't know what's going on there. That's going to be a brand new concept that's never been covered even in previous math classes. So it's going to be really imperative to work around this by having a starter activity, a bell work activity that's very, very easy or scaffolded into the full approach here. Well, we're just going to use a number line, an x-axis only, and we're going to work both ways. I'm going to give them the values. That's typically the easiest. Give them the values on the number line, and they're going to report back with parentheses and brackets and which ones are closed and open, and they're going to decide that interval which the solutions exist from where to where, left to right again. Okay, and then we're going to work that to where I give them the values, and then they graph it. We're going to work both directions. Then we'll be able to work for an XY axis. So we're just going to start with an X axis, then they'll be competent enough to be able to go to an XY axis. Again, they won't have mastery of this skill, but at least they have seen it before we get into that integration part in the lesson on Amplify. Okay, my references are listed there. I want to thank you for joining me.